This is going to go over question number 4 from 2014, which was also a variety of topics. There was a table-based question, so we've done some table-based questions, but this one asked a few different things, so I liked it compared to maybe some of the other ones that we did. So here we go. Question 4, part A, wanted the average acceleration of train A, and you're given a table that shows the velocity of train A. Acceleration is the derivative of velocity. If you want the average acceleration, it's like you're doing like a basic slope. Like the average derivative would be just the slope over the course of time. So what that means, if you're going from 2 to 8, is you're going to look at what's the velocity of 8 minus the velocity of 2 over 8 minus 2. So my work kind of wrote what I just said. Acceleration is the derivative of velocity. So here's my velocity at 8 minus my velocity at 2 over 8 minus 2. You get negative 220 over 6, which you can leave it. You can reduce it if you want. I wouldn't take too much time to reduce. They didn't specifically ask for a unit, but it is acceleration, so it'll be meters per minute squared or meters per minute per minute. Scoring wise, they gave only 1 point. So their work, the units, that wasn't something they were really focused on. As long as you had something equivalent to negative 110 over 3, you would get that point. Part B wanted to know, is the data enough to know that at some point the train's velocity would be negative 100 between 5 and 8. So the key here is that it's a continuous function. If they tell you something's differentiable, that automatically means it's also continuous, then it can't miss a point. Every point in between, like point A and point B, it has to hit. It's actually called the intermediate value theorem, which I very rarely reference the name. I kind of talk more about the idea. So if you look at from 5 to 8, from 5 it has a velocity of 40, and at 8 it has a velocity of negative 120. Since it's continuous, somewhere between 5 and 8, it has to hit negative 100 because negative 100 falls between 40 and negative 120. So I'll show you how I wrote it. I wrote differentiable means continuous. This is just my quick abbreviation. And then I kind of stated in words what I just said to you guys. The time at 5 was 40 velocity. The time 8 has a velocity of negative 120. Because it's continuous, at some point it has to equal negative 100. What did they say? They actually do quote the intermediate value theorem. Truly, that is just a theorem that says to get from point A to point B, if you're continuous, you have to hit every point in between. And then said that it has to be somewhere in between. As long as you in some way reference that negative 100 falls between 40 and negative 120, and you talk about it being continuous, you're going to get full credit. You do not have to name the actual theorem to get full credit on that. Part C wanted to know, starts talking about the train's position at 2 being 300 meters east, and it's continuing to go to the east. And it wants to use, first write an expression that has an integral of the position at once we get to 12, and then use a sum to actually find the position at 12. So this is an idea, again, integrate to accumulate. If you integrate velocity, you get position or your location that you've traveled. So you start at 300. So that's why I have a plus 300 at the beginning. And then I know if I integrate from 2 to 12, that integral of the velocity, I'm going to get that location, that position where I've ended up moving. So that's how we start. But then they want you to do a trapezoidal approximation. I feel like the ones we've been doing lately have been more Riemann sums, where you're splitting it up into rectangles. So I like that this one was something different. Trapezoid is 1/2, and that's for every trapezoid, so you can put it out front. And then you're going to take the height, which is the distance between those time values, times base 1 plus base 2, which are those velocities. So my first one has a height of 3, and the bases are 140. My next one has a height of 3, my bases are 40 and negative 120. My next one has a height of 4, my bases are negative 120 and negative 150. Now, on the test, you will be able to use a calculator. This obviously was designed to not use a calculator, but it's time consuming, so I would use one. So I multiplied these all together. Then I took it times 1/2. You end up getting negative 450 plus the 300, because that's how far east you were to start. You get negative 150. Now, what that negative means is it's directional, because velocity always has a direction. So if we're thinking the positive direction being east, then the negative direction would be west. So what I end up finding is that after this time 12, I am 150 meters west of the origin. They call it the origin station. So here's how they score it. If you expressed it as a expression with an integral, and I didn't get nearly as fancy as they did, I just went right here, and I think that's full credit that it's the 300 plus the integral. That's 1 point. 1 point is showing you understand how to do a trapezoidal rule. I did all the half out front. I didn't do the half individually to get the negative 450. And then the last point is that you realize when you add those together, you get negative 150. I wouldn't take the time to explain direction, since velocity has a direction, that would be west. And then finally, part D. I thought part D was a very different type of question, which is why I like it. Part D was a related rate question. So what you have here is now you have the second train coming in, but this train's traveling north. The train A is traveling east, and we want to find at the once we get to a time of 2, how far is the distance between them changing. So this is like the ladder problem, I guess is the best way to explain it. I drew a picture. Nobody's grading your pictures on an AP test, but it helps me. So here's train B heading north. Here's train A heading east. And then here's what I'm trying to find is how fast that distance between them is changing. So I called them A, B, and C, and then my derivative would be dA dt, dB dt, and I'm looking for dC dt. So I set it up as a Pythagorean, a squared plus b squared equals c squared. Very easy to take the derivative. Every one is going to have a 2 in front of it, so I just canceled the 2's. You could leave it. You're going to get the same answer. Then I'm going to plug in what I know. I know at time 2, B is 400. They gave that information. At time 2, A is 300. They gave that information. That actually is from what we found in, used it for what we knew in part C. And then to find C, this is a Pythagorean, a squared plus b squared equals c squared. I already knew, I saved some time, that this would be a 3, 4, 5 triangle. So C has to be 500. So I plug that in. And then finally, your derivatives. Your derivative, your A derivative at 2 is 100. That comes from the table. Your B derivative at 2 is the velocity at 2. And that, my work is way up here. I just couldn't find any other place to put it. So I put 2 into that velocity equation, and I got 125. That is going from this equation that they gave right here, this V sub B equation. And that's going to be equal to 500 times dC dt. Use a calculator for this. You end up getting 80,000. Divide both sides by 500. You end up getting 160. That is a velocity change, so that is meters per minute. So the scoring on that one, and again, I thought part D was the most challenging just because it was so different than the rest of the parts. So you get 2 points for showing that differentiation of the a squared plus b squared equals c squared, or they called it x, y, and z, and showing all those kind of pieces. And then you only get 1 point for the answer. So basically, you could do a lot of this in your head or a lot of kind of off to the side work. They're not going to grade. As long as you get the 160 meters per minute, you get the third point. I'm not sure how picky they would be with these top parts. My guess is if you took the derivative of the a squared plus b squared equals c squared but didn't know what to do with it, you probably get 1 point. If you were able to start putting values in for your a and your b and your derivatives, that's where you're going to get your second point, and then your last point is for your final answer. So again, number 4 from 2014. I'm going to continue making the videos so you can see what number 5 looks like, and then number 6, and then ask for a score report. Thank you guys. Talk to you soon. Hope all is well.